Hi, I'm Deepak Upreti, and this is a project report on web filtering for SMI course. My team members are Aditya Lunawat and Tushan Jain, and we were mentored by Shailesh Jain. So here comes the objective. The objective of our project was to do web filtering on SMS. So web filtering, as the name suggests, is a platform for identifying the normal content and the unwanted content, which is to be identified and removed. So by normal content, we mean it can be a normal message or email, and we can apply any filter, any custom filter based on, like, we can say if the email contains some images or some particular phrase, then filter it. And the later, that is unwanted content, is normally referred to as spam. Spam is flooding the system with many copies of the same message in an attempt to force the message on people who would not otherwise choose to receive it. Basically, spam is used for commercial advertising, often for dubious products, get rich quick schemes, or quasi legal services. So, the challenges that we faced, that is, unlike emails, database for spam or messages are very limited. SMS have a limited length, number of features that can be used for classification is normal. Features being small needs the algorithm to be smart enough to differentiate between the messages. And the text messages generally include abbreviations, informal language, that is text speak, or other languages written in English. Like we can do combination of English and Hindi language also, and we do not write the exact word, and we write it in some short form. So the data set, like we use the data set, that is UCI machine learning repository, that contained collection of SMS messages. So we took the dataset from GrammarTech's website, NUS SMS corpus, and Caroline Tagg's PhD thesis. So a total of 5574, that is 5574 messages that we analyze. Out of them, 4827 were ham messages and 747 were spam messages. So the dataset consists of one message per line, that is each line is prefixed with a ham spam label separated by a tab. And so we have worked on the dataset to categorize it into spam or ham. Now the approach or the algorithm that we followed. Initially we split the database, that is 70% into the training data and the 30% to be the testing data. And then the classifier was made to run using the training data, and then the accuracy was calculated. Accuracy is being calculated using the testing data. The training data is read line by line, and the label and the messages and the label and the message are separated from the remaining message content. These both are being stored in a data structure and are brought into memory. So next, the messages are tokenized. Only the tokens which were pure alphabetical characters are stored. We ignore the punctuation marks, special characters, all those we ignore them, and then we count then we maintain a frequency count for each token, and for each message we stored it as a bag of words. We do not do stemming here, but the stop words are being removed. And along with the attributes, we also included three extra attributes per message. That is the number of dollar signs, the number of numeric strings, and the length of message. Now we remove tokens which occur less than 5 and more than 500 times. That is, we thought that it would be noisy feature. So to normalize it, we did all these things. Now overall 1505 features were total. We collected total 1505 features in the whole data set. Now coming on to the feature vectors. The feature vectors for each message are computed with their frequency counts as values. The three extra attributes are also taken as features with their values per each message. Now the classification. The naive-based classifier is used here. Multinomial event model of NB is used, as it is useful for feature vectors with word counts. Laplace smoothing is used in NB to handle cases where the feature vectors word counts are 0. Coming on to the results, the training of the classifier is very fast. testing takes far less time. The accuracy computed by the tester by testing the classifier on the 30% test data is 97.43%. Now, coming on to the experiments and the observations, we train the classifier on 100% of the training data and try to classify SMS corpus given to us, consisting of 65,257 messages. Some of those messages were repeated in that corpus many times. The classifier labeled 636 messages as spam and 47,345 messages as ham. There were false positives and false negatives, but occurrence of false positives was greater than false negatives. The reason was because the classifier associated with the label spam with features, length of the message, numeric terms, and word features called such as free, call, urgent. Now, presence of false positives and false negatives was because of the message content having other language text, Hindi, that is Hindi, Chinese, typed in English and mixed with regular English content. That is, we type the Hindi words in using the English alphabets, so it is difficult to identify them and their meaning. Some of these words are unseen in training data to some extent, but they are handled by Laplace smoothing in the training phase to some effect. This scenario can get improved accuracy. We can introduce some features which can use ratio of capital words to small words, ratio of small words to normal words, consider more different currency symbols, and the number of URLs in the messages. So we use certain references here, references in our project which are mentioned in the screen. And so overall the results were quite satisfying and it was quite accurate. That is 97% is I think quite accurate. So I want to thank the mentor and the sir for giving us the opportunity to work on this project and get to learn a lot of things. Thank you.